Dear colleagues, I'm happy and excited to share with you the current status and the innovations in the digital workflow in full arch implant rehabilitation. And today's webinar will be focusing on the treatment of the completely edentulous patient and not the terminal dentition. So we will be focusing on how we apply digital workflow for treatment of patients that are already edentulous. So we have a lot of material to cover, and we will jump right into it. So the presentation will discuss the digital technology applications in the workflow for full arch implant rehabilitation. We will review the scientific evidence. We will run a case from A to Z that the patient received definitive rehabilitation with digital workflow, and we will draw some conclusions. So before we start, what is the incidence of complete edentulism in the United States, since we're going to be talking about completely edentulous patients. So according to data from the American College of Prosthodontists, in the United States, the percentage of edentulous patients is 10% of the total population, approximately 35 million Americans, and this number is expected to increase mainly because of the increase of life expectancy. Patients and people live in general longer, and that's why we are expecting to have an increase in the amount of edentulous patients. About 23 million are completely edentulous, and about 12 million of them are edentulous in one arch. Here you see a patient on the left, completely edentulous on both jaws, and on the right, the same patient rehabilitated with a double full arch implant fixed prosthesis. We can achieve this outcome both with the digital workflow and with the conventional workflow. But why digital? Digital technology provides a platform for treating the completely edentulous patients in a streamlined and efficient way with predictable outcomes. But that does mean that digital technology will treat the patient. We need strong fundamental surgical and prosthodontic skills, and digital technology will only serve as the vehicle and the platform to serve this purpose and take us from start to finish. So let's see the 4 different fields that digital technology is applied in the workflow for treating the edentulous patient. It can be, of course, in the diagnostic phase with digital planning, and that is an essential part, an integral part of the treatment. After we do the planning, we can bring it to life with guided surgery, and we can use mucosa-supported templates to place our dental implants, guided. Once the implants are placed, the prosthodontic phase starts. After the implants heal, we can take an impression. This can be a digital impression with an intraoral scanner. And finally, we can use CAD/CAM technology to fabricate the final prosthetics. So first things first, digital planning. And edentulous patient comes to our clinic. Patient can have no prosthesis, or he can have a removable complete denture. The first thing we do is assess the existing prosthesis for aesthetics, function, and phonetics. If the aesthetic, functional, and phonetic requirements, the vertical dimension, the maxillomandibular relationship are satisfactory, then we can use this prosthesis as a radiographic template. If this prosthesis does not serve the requirements for aesthetics, function, and phonetics, then we have to make a new prosthesis, or at least a setup. Assuming that, like in this case, the patient has an ideally fabricated denture, then this denture will become the radiographic template. How does this happen? Well, we have to put fiducial markers prior to taking what we call the dual CBCT scan. And what is the dual CBCT scan? A dual CBCT scan is a procedure, and the patient is wearing a radiographic template. In this case, the ideally fabricated complete denture becomes the radiographic template and is receiving 2 scans. The first CBCT scan is with the radiographic template placed in the mouth with fiducial markers, and in this case we can put gutta-percha points or self-adhesive stickers with radiopaque fiducial markers, as you see here in the photo. And the patient undergoes the first CBCT scan. After the first scan, the prosthesis is removed and is being scanned again, just by itself, as a second scan. After we are done, the 2 CBCT scans generate DICOM files. So these 2 DICOM files are exported and then re-imported into a digital planning software where we can perform our digital planning. There are uncountable amount of digital planning softwares in the market. For this one, we used the code diagnostics from Straumann. You can see the beautiful representation of the teeth, the underlying tissues, the bone, the soft tissue thickness and height, and of course anatomical structures like the inferior alveolar nerve and the pneumatized sinus, as you can see here in this case. So once we perform virtual implant placement, we can elect if we're going to proceed with guided surgery or if we're just going to go ahead and perform conventional surgery, but at least we have performed digital planning and we know what to expect. There are plenty of advantages with digital planning, and namely the first one is prosthetically driven implant planning, because patients come to us to get teeth and smile. Patients don't care about implants, how many implants you will place, what type of implants. Patients want teeth and smile. And we have to place the implants in such a way, in such a fashion that they will support the future fixed prosthetic restoration. Very important. Second is the simplification of the surgical procedure, because we have already performed the surgery virtually, and especially if we couple it with guided surgery, we can make it even simpler. Reduction of intraoperative stress and time is a very important advantage, and this is something that is very gaining popularity in the medical literature. The clinician performs the digital planning in advance, so he knows what to expect, and that reduces a lot of the intraoperative stress and of course simplifies the procedure and reduces the time. Time reduction is also good for the patient because it reduces the postoperative discomfort, and especially if we couple it with guided surgery and potentially flapless procedure, this makes it so much more comfortable for the patient. Finally, and to me this is what I call digitally planned prosthodontics, it is a very important advantage of digital planning, and that relates not only to the implant angulation, but also to the implant depth, which is very important for the full arch implant restoration because it is directly related to prosthetic components and the prosthetic space. You will hear so many people talk about the prosthetic space. What if we use a metal acrylic restoration? We need more space, 15 millimeters. What if we use a zirconia prosthesis? We need 10 millimeters or more. So all these things are directly related to the definitive restoration and to the structural integrity and strength of the definitive restoration. So digitally planning our prosthodontic treatment has the advantage of selecting the components in advance so that we can even perform immediate loading, and of course controlling the prosthetic space for the definitive rehabilitation stage once we reach it. There is no really any disadvantage for the digital planning other than the cost for the software and the surgical armamentarium. However, most of the companies, once a clinician decides to buy a big batch of implants, they will offer the surgical armamentarium for free. Now, once we planned and are happy with the implant position, then we can bring this plan to life with guided surgery. That's also a routine procedure, so I'm not going to spend a lot of time with that because we will be focusing on this presentation more on the prosthetic phase. But let's run quickly to see what are the current innovations and status in guided surgery. Guided surgery is being performed with the mucosa-supported template. As you can see with the images here, they are fixated. The mucosa-supported templates are fixated into the bone intraorally with fixation pins, anchor pins, and the osteotomies can be done through these metal sleeves, and of course the implants are placed through the metal sleeves. This can be done after flap elevation or before flap elevation, and then we lay a flap and graft if we need to, and when there is adequate amount of bone and adequate amount of keratinized mucosa, we can even perform flapless guided implant placement, as you can see on the bottom images. Now, let's run a case to make a point, and we will start from A and we will go to Z, and it will demonstrate from planning to guided surgery to digital impressions and of course to CAD/CAM prosthetics. So patient comes to our clinic, dentulous maxilla. Patient has a complete denture which is assessed for aesthetics, phonetics, and function. If in this case it was ideal, if it is not ideal, we have to redo a new setup or a new complete denture, and then we feed everything into the pipeline for the digital planning workflow. How does this become? A satisfactory denture is used as a radiographic template. So the denture/radiographic template will be used to take a dual CBCT scan. How do we do it? We attach a minimum of 6 fiducial markers. In this case, we use these fiducial markers, which are self-adhesive stickers, very easy to use. And pay attention here, because these stickers you will see later during our intraoral scanning. It's a fantastic tool that you can use as a clinician to relate scans, CT scans, and files. So the DICOM files after the dual CBCT scan are fed into our implant planning software. Virtual implant planning is done, and we can bring it to life via 3D printing, as you can see here. So we 3D print surgical template. Guided surgery is done. I'm not going to go into how we do the guided surgery. And once the implants are placed, of course, we assess the implants for primary stability. We have plenty of literature to support that immediate loading for both maxilla and mandible is a routine procedure now. We need minimum of 30 Newton centimeter implant stability. We achieved that, more than that actually, in this case with the bone level tapered implant that we used. After insertion torque assessment, we torqued the multi-unit SRA abutments, and here you see the parallelism with the guide pins. And then we do the so-called conversion prosthesis technique, which the denture will become a fixed provisional restoration. How do we do that? We hollow out and perforate the denture to allow for the temporary abutments to be placed. We isolate from the wound with rubber dam. We seal the screw access channels with Teflon, and then we pick up with acrylic resin the temporary abutments. Then we trim and contour the denture, and this is how it looks after delivery. So guided surgery can always be coupled with immediate loading, and it can lead to a very satisfactory outcome and a happy patient. Now, what is the evidence for the accuracy of guided surgery? How accurate is that? So the evidence comes from the recent 6th ITI Consensus Conference that was held in Amsterdam in 2018. And each ITI Consensus Conference takes place every 5 years. And 150 experts approximately from all over the world are invited, and they're divided in 5 groups. Each group has subgroups, and each subgroup is assigned to have a task of running a systematic review on a topic, on a clinically relevant topic. In this case, the group that had the task to run the systematic review regarding the accuracy of guided surgery was the group from the Netherlands. And what they found and reported was that the difference between the deviations, the 3-dimensional deviations of the implants between the digitally planned positions and the actually placed are about 1 millimeter at the entry point and about 1.5 millimeters at the apex. And bodily, we can expect about 3.5 degrees of angulation. This was published in 2018. This, of course, was presented in the plenary session in front of all the experts, and the clinical recommendations were clear that guided surgery for the treatment of the full arch edentulism is a safe procedure and a great tool in our armamentarium. And now we go to the third field that digital technology can be applied in the workflow for full arch implant rehabilitation, and this is a field that is so dynamic and constantly changing, and it is such an exciting field to do clinical research and treat patients. So that starts with the prosthetic phase after the implants integrate starts with the impression. The impression can be either a conventional impression or a digital impression. So for the conventional impression, we connect impression copings, and we always splint them with a splinting material. It can be triagel, it can be pattern resin, it can be composite. It doesn't matter, the splinting material. We will splint them and then use an open tray, an open custom tray with elastomeric material, either polyether or PVS, and take the impression. What is the evidence for the accuracy? There is a ton of literature clear on the topic, definitely supporting the open tray splinted full arch impression technique, and that is the most accurate technique that we use and represents the golden standard nowadays. So for every full arch impression, we connect abutment level impression copings, splint them together, section sometimes the splint to allow for depolymerization shrinkage, reconnect, and then use an open tray impression to capture the implant three-dimensional position. What about digital now? For digital impression, it's quite similar. Instead of impression copings, we will position scan bodies, and we also will tighten them. It's the same fashion. No need to splint this. Just the use of an intraoral scanner is enough to take multiple two-dimensional photos, which will be stitched into a three-dimensional video. And this creates what we call an STL file, a standard tessellation language file. And this file can be imported into your CAD software. So it is a three-dimensional representation of the intraoral situation. It is saved as an STL file and it can be imported into a CAD software so that we can start designing the prosthesis. But why digital? Why digital? We have this splinted open tray technique, which is reliable. It has been used for many years and it always gives accuracy of fit. But why digital? So the digital implant impression can eliminate the tray selection, the dispensing and setting of the material, which sometimes is associated with polymerization shrinkage. To disinfect the material and the impression, also you eliminate the need. Plus, you eliminate the impression shipping to the laboratory, while increasing patient comfort because sometimes some patients might be sensitive and have a gag reflex. So loading a tray and putting the whole tray with the excess material running on down the palate can be objectionable to some patients, especially the ones that have a severe gag reflex. This is eliminated with digital impression. Additionally, digital impressions can increase the efficiency since it is possible to email the file to the lab and store it electronically, while it eliminates space management issues and supports a paper-free practice and efficient record keeping. But what is the evidence for the accuracy? You will hear everybody asking, digital impressions, but how accurate are they? So let me show you what the literature says about that. The literature is available. We actually ran a systematic review and meta-analysis from our team, and we systematically reviewed in vitro and clinical studies comparing quantitatively the three-dimensional deviations of digital and conventional of implants after digital and conventional impressions for both partial and completely dentulous patients. But this presentation will focus on the completely dentulous, so I will share with you what we know from what is the evidence for the completely dentulous patients. This paper was published in the Journal of Prosthodontics last year, and the outcomes that we found were the following. The difference between conventional and digital impressions was 50 microns. That was not even statistically significant, and it was actually nominally favoring the digital. So when we compared digital and conventional impressions, there was no difference. Full arch digital impressions have similar accuracy as conventional impressions. And that was based on 9 in vitro and 1 clinical comparative studies. There was a ton of in vitro studies comparing digital impressions without control groups, but these were excluded. Most of these studies were showing accuracy for the full arch digital impression. But here we only used comparative studies. So 9 in vitro, 1 clinical study. And what we did is we drilled deeper into the data and we tried to assess the effect of the scanner on the accuracy. So what we found available in the literature was based on two scanners, the TrueDef versus the conventional and the Trios versus the conventional, and no difference was found. So the effect of the scanner does not play a role on the accuracy. Now, I showed you that this information is based mainly on in vitro studies. The clinical study that we included was part of a prospective study that we have been running at the University of Rochester with the team that we are collaborating under Dr. Chochlidakis, the director of PG Prosthodontics at the Eastman Dental Center. And this prospective study is including 16 patients with a dentulous maxilla. So we treated 16 patients with a dentulous maxilla. Every patient received 4 to 6 implants, and immediate loading was applied, and the denture was converted to a fixed restoration. So this prospective study has different arms. One arm is the implant survival at 1, 3, and 5 years. We recently submitted for the 1 year follow-up results. And the other arm of the study includes the accuracy, a direct clinical comparison of the accuracy between digital and conventional impressions. So let me go over the study that we did. So after implant integration, all patients presented for final impressions, and the conventional group received splinted open tray abutment level impressions, whereas the digital approach included an intraoral scanner, in this case was a true definition with a powder, and an intraoral scanning of the scan bodies. And both impressions were saved. Now, for the definitive rehabilitation of the patient, we used the stone casts generated from the conventional impression group. So the conventional impressions were poured with stone master casts were created. We did the verification jig for each and every of those 16 patients. It is very clear in the literature that you need to verify your stone master cast. So all the stone casts were successfully verified. All 16 of those were accurate with the open tray splinting technique, and they were used into the final phase of fabrication of a definitive titanium bar and wrapped around with pink and white acrylic in order to fabricate a metal acrylic resin restoration. These restorations were fitted in the patients. All of them presented with accurate clinical fit, both clinically and radiographically. And once confirmation was done, they were delivered. And here you see the 1-year follow-up of maxillary Olon 6 case. And this is the publication that has been submitted by Dr. Hochlidakis. Now, you saw that all the stone casts generated from the 16 impressions of the 16 edentulous patients were accurate and clinically verified. So what we did, we started our clinical study and we digitized those casts. How did we digitize them? We scanned them with a high precision reference scanner, and this created an STL file, as you see on the right, and we saved this STL file. Of course, we took an intraoral digital impression as well, as I told you. And this created an STL file, and that STL file was also saved. Now, these two STL files for each patient, both were imported into a reverse engineering software that you can see here. It's called GeoMagic. And the best fit algorithm was used to overlap and superimpose the scan bodies and assess the three-dimensional deviations between the conventional impression and the digital impression. You see here a color gradient map demonstrating the three-dimensional deviations between the implants. Here are the results with standard deviation, mean, minimum, and maximum figures. The total cumulative three-dimensional deviations were about 160 microns. And that is within the clinical threshold reported by GEMT of 200 microns. We know that everything that has less than 200 microns of deviation is clinically acceptable. That was the threshold reported in the literature regarding clinically acceptable fit. So, digital and conventional impressions, similar accuracy, deviations are within the threshold for clinical fit. We are running actually multiple studies right now and taking it one step further by creating prototypes and printed casts, and we will elaborate on that in the continuation of our presentation, and it's very exciting. This is very innovative stuff, and I'm thrilled to share it with you. For example, you can see that digitally fabricated prototypes were fabricated and are being fitted on the verified stone casts, and you see the perfect fit. So whether you follow the digital workflow or the conventional workflow, you can get an accurate fit of the prototype, which will be tried in the mouth, copy scanned, and copy milled later. So we have an accurate STL file. That's what the literature and the scientific evidence shows. But the question is, now what? What do we do with that STL file? Before we go ahead and I show you what we do with this accurate STL file, let's see what we do during conventional prosthodontic workflow. So a patient is a dentulous, we will place implants after digital planning and guided surgery. Patient will be immediately, the implants will be immediately loaded or will be loaded after implant osseointegration. You see here the full arch provisional prosthesis, maxillary and mandibular ones. And patient is happy with the aesthetics, phonetics, and function. So is the clinician. So once we are happy with the provisional restorations, then we can move to the definitive rehabilitation. So for the conventional prosthodontic workflow, we need as minimum as 4 visits. Let's see all the steps. So the first visit, starting the definitive rehabilitation, includes impression of the implants and impressions of the prosthesis. So we will take impregam impressions of the implants with a splendid open tray technique, and then we will also take alginets or PVS impressions or impregam impressions of the provisionals. And we will pour them with stone. On the second visit, the poured master stone casts and the provisionals will be cross-articulated of the stone casts so that we have the maxillomandibular relationship at the appropriate vertical dimension. Traditional prosthodontic workflow. On the third visit, we will scan the cross-mounted cross-articulated casts, and we will fabricate prototypes. We can mill them or print them, depending on the technology that we have our laboratory is using. These prototypes will be tried in the mouth at the third visit, and after we make some adjustments, minor or major adjustments in terms of aesthetics, occlusion, buccal corridors, or whatnot, then they can be copy milled to the final restoration, and the fourth visit includes the definitive insertion of a monolithic zirconia prosthesis, like in this case, and you can see the post-delivery panoramic X-ray. So this is how we do it conventionally. But how do we do this digital prosthodontic workflow? Similar fashion, we will take impressions of the implants with the scan bodies, and we will take an impression of the provisional. The problem is that we cannot cross-mount anything here because we don't have any fiducial markers. If patient has teeth, we can use teeth as anatomical fiducial markers to overlap the two files. For the edentulous patient, there are no teeth, no other landmark. So we only have the soft tissue, and the soft tissue superimposition is unfortunately inaccurate. So the STL superimposition is what we call the Achilles heel of the workflow. Lots of groups have tried to solve this issue, and there are plenty of reports. I'm going to go over some of them here. They have tried to use a PIP paste or these flangeless, palatless setups in order to use superimposition based on the soft tissues, but this may be inaccurate. Other groups have tried to 3D print different devices so that they can facilitate the scanning, but this does not offer any information in terms of the teeth and the tooth position. So it is not as clinically relevant, and it may be expensive to have to fabricate another 3D printed prosthesis. Another report has used the mini implants or mini TADs, orthodontic screws, to be used as fiducial markers. And this is something that can be used, but it may be invasive and objectionable to some patients because it includes a surgery of placing them and then removing them later. So what we developed the solution to this problem of to the STL superimposition. It's with what we call this double digital scanning or DDS technique. So the DDS technique can capture the STL data with the double digital scanning, can facilitate the STL superimposition, which is the key for precision, can copy transfer all the relevant patient information to the technician all in one session, and can shorten the treatment time. How amazing is this to have the ability to shorten the treatment visits predictably, reliably, both for our benefit and of course for the patient's comfort and benefit. So we've been working with this technique for about 3.5 years. The first paper got published back in 2019 at the Journal of Prosthetic Dentistry. Since then, another 3 publications have followed. And we are currently have a lot of clinical and preclinical studies in the pipeline to be submitted for publication. So let me go over the technique with you. So a dentulous patient received implants a fixed prosthesis was done. In this case, was immediate loading. And after 3 months, patient comes back, everything is successfully integrated, the prosthesis serves adequately for aesthetics, phonetics, and function, and we are ready to move forward. If the prosthesis did not, during assessment, was not satisfactory, we could fabricate a new provisional prosthesis. So for this case, the prosthesis was acceptable, and we move forward. So what we do, we attach a minimum of 5 fiducial markers or keratinized mucosal areas, such as the hard palate and the alveolar ridge. Why? Because keratinized mucosas are non-mobile and it can serve as fixed and solid landmarks. After we place at least a minimum of 5 fiducial markers, the first step is we take an intraoral scanner and we scan the edentulous arch, including the provisional prosthesis and the soft tissues, with the attached soft tissue markers, as you can see on the video on the right. This will produce an STL file, as we saw earlier, and this STL file will be saved in our computer. Now, after that, we will remove the provisional prosthesis and we will place scan bodies, as you can see here, without removing the fiducial marker. So we will connect implant scan bodies on the multi-unit SRA abutments, and we will use the same scanner to scan again the scan bodies and the soft tissues this time with the fiducial markers. And the STL file that will be generated will be also saved. After we finish with the double digital scanning, then we can reinsert the provisional prosthesis, and before we send the patient home, we will scan the opposing arch, in this case the mandible, and we will also scan the buccal aspects of the interim prosthesis in centric occlusion with the opposing dental arch, so that we can register the bite, the maxillomandibular relationship. All these files will be saved. What we do with these STL files? These STL files now can be imported into our CAD software and superimpose them with the aid of the markers. This is the beauty of this technique, that the two STL files can be fused together in one master STL file that has, and this is the unprecedented information that we have. It has the tooth position, the buccal corridors, the incisal ledge, the midline. There is no need for the occlusal plane, the aesthetic plane. There is no need for a digital face anymore, because everything is engraved on the provisional. If the provisional prosthesis is ideal, everything is engraved on the provisional prosthesis. And this simplifies the procedure, because all the information now can be reliably copy transferred with one master STL file that has both the tooth position and the implant position. Now, let's assume that we even want to change something in the existing provisional. We can register this information and we can change that with a digital setup, as I will show you here. For example, we can shift the midline, we can increase the incisal length, we can reduce the corridors, we can add on the buccal corridors, and so on and so forth. Here you can see the prototype designed, copy design from the existing prosthesis with some minor modification, and you can see some space in order to receive the SRA variobase abutments. So this is how our digitally designed prototype looks like, with space for ping in order to compensate for the hard and soft tissue missing tissues. This is how it looks like digitally before it is milled. And this is how it looks after it's milled, and the variobase abutments can be cemented with a cyanoacrylate glue or Panavia inside the female part of the prototype, the prosthesis prototype, and this can be tried in the patient's mouth. We clinically evaluate the prosthesis prototype and we adjust if necessary. We can do some minor adjustments or some major adjustments, it depends. Use the screw retain test, use the screw resistance test and periapical radiographs to assess the clinical fit of the prosthesis prototype. Now the question is, does this prototype fit? And the answer is yes. This prototype, this totally digitally fabricated prosthesis prototype fits. There is ongoing clinical research and preclinical research that we have completed and we are about to submit, with fantastic outcomes in terms of the clinical fit of this totally digitally fabricated prosthesis prototype. So you can go from the double digital scan with the DDS technique and completely, with a complete digital workflow, fabricate a prosthesis prototype that you can try on the next visit and it will fit. That's unprecedented tool that we have now in our armamentarium. It shortens the treatment time, it shortens the treatment visits, simplifies the treatment, and of course reduces the cost, which is something very important. This is how the digitally fabricated prototype with a complete digital workflow looks like. And after minor modifications, we copy, scan it, and then we can mill a monolithic zirconia. In this case, we did minimal cutback and veneered the facial of the monolithic zirconia prosthesis on the gingival portion only with porcelain for enhanced aesthetics. So this is how it works. Now, what about DDS, double digital scanning for the mandible? We saw that in the palate, it's easier because we have the keratinized mucosa of the palate. It's much easier. What about the mandible? Always this is a question. So let's assume a patient received the implants with the guided surgery and adequate stability was present for the implants and the immediate loading was performed. So in this case, I'll show you a paper we just published in the Journal of Orthodontics that allows for a complete digital workflow also for the mandibular jaw. And you can actually finish the case in only 3 visits. Another unprecedented possibility that you have with the digital technology. And how does this work? It's the same concept, DDS technique. You scan the provisional and you scan the scan bodies, but you will superimpose the 2 files with the aid of the anchor pins. The anchor pins that were retaining the mucosa supported guide can be now used as fiducial markers. So let me go over. You see here the first intraoral digital scan with the scan bodies in place and the anchor pins after we suture the flap. We had to spray a little bit of powder just to prevent and reduce the reflective nature of the blood that was oozing from the flap. So here you see the raw STL file saved after the first intraoral DDS scan. And then we put the provisional prosthesis and we take the second DDS scan with our same scanner. This is the raw file after it is saved. So what do we do with these 2 STL files? Similarly to before, we will superimpose these 2 STL files. We will import them into the planning software, into the CAD software, and we will use the anchor pins to overlap the 2 files. And you can see here, it's so easy. We need minimum of 3 fiducial markers so that we can orient them in the space. Perform alignment, and now you see unprecedented information. This master STL file has all the information regarding tooth position, midline, aesthetic plane, occlusal plane, buccal corridors, implant 3-dimensional position. So everything is here. And this can be used for the fabrication of the prosthesis prototype, as I showed you earlier for the maxilla. Here are the files in the CAD software. In this case, we used the ExoCAD one, but any software can be used for this process. Now you see the superimposed STL master file is used to fabricate the prosthesis prototype. You can either 3D print a prosthesis prototype or you can mill it, either or. And we can glue the Vario-base SRA abutments, the multi-unit abutments, and that prototype is being tried in the patient's mouth. And after some minor occlusal adjustments, it can be copy-milled into the definitive rehabilitation. In this case, it was a double full arch rehabilitation with the monolithic zirconia, only with minor gingival cutback to allow for the veneering porcelain and the missing soft and hard tissues. Here you can see the panoramic, beautiful bone levels, and this is the definitive rehabilitation. This was done with a complete digital workflow. And we recently published that in the Journal of Orthodontics this year. Now, as I said, yes, you can do a complete digital workflow. Do the prototypes fit? Do the prosthesis fit? And the answer is yes. We have ongoing data from a multi-center clinical study that we ran with 3 universities and 2 private practices, and implementing the DDS technique, comparing actually also digital and conventional impressions, one arm of the study, fabricating digitally fabricated prototypes with a complete digital workflow with the DDS technique as a second arm of the study, and the results are very, very promising. We will soon be publishing the information. As a treat though to the audience, I will show you another update, the most current innovation for the DDS technique. So I will show you what about DDS for the implant for the mandible, not at the time of surgery, because maybe we cannot immediately load the implant. So we cannot apply the DDS technique with the anchor pins. So what happens to a patient that has already received the implants and then comes to our office, we do a provisional restoration and is ready to move forward. We cannot place again anchor pins because it will be unethical or objectionable to the patient. So we can use the keratinized mucosa, but there is not enough keratinized mucosa usually on the mandible, especially on those class 2 patients with the over-contoured provisionals. There is no way to place the stickers, the markers. So what do? So we developed a technique with Dr. Marinis, my good friend, a prosthodontist, and we recently published that, actually just published that in the Journal of Prosthodontics, by using a novel scan body that the guide pin is interchangeable with a temporary abutment. And this is the key. This is the key, dear colleagues. Having a guide pin that is connecting the scan body to the implants and also having a guide pin that is totally interchangeable that connects the temporary abutment to the implants. And you can see here with those heads, we can overlap the two files from the DDS technique, both the intraoral scan of the scan bodies and the intraoral scan of the provisional. How we will overlap? We will use the heads of these guide pins. So whether you do that at the time of implant placement or whether you do it at the time of after the implants heal, it simplifies the procedure and makes it predictable and applicable to any clinical scenario. It is a fantastic way to do it. You see here the prototype, completely digitally fabricated, tried in. We added some pin composite to replicate the missing hard and soft tissues, tried in the patient's mouth, minor adjustments, and then we copy mill that into the final prosthesis. So, a lot of information. The current status is constantly changing. There is constant innovation. Digital impressions are growing, and from experimental, currently being experimental, they soon most likely will be a routine procedure. We will elaborate on that towards the end of our presentation. So the fourth field now that we can apply CAD/CAM technology is for the prosthetic fabrication. And there is a ton of literature regarding that. That's not even addressed any longer because there is so much literature supporting CAD/CAM technology, from a single custom abutment to a 3-unit prosthesis, a multiple unit prosthesis, a full arch zirconia prosthesis, or a titanium framework. We apply CAD/CAM technology every day in our definitive rehabilitation, from a single to a full arch case. So there is a ton of literature on that supporting. And the important thing now is how do we fabricate the prosthesis. There are two methods. There is a subtractive method, which is the milling, and there is also the additive manufacturing method, the 3D printing, which is also a hot topic and currently under investigation. Now, the current standard for prosthesis fabrication is milling. And when we say milling, the first thing that comes to our mind is, of course, zirconia. Zirconia can be a porcelain fused to zirconia framework, which means framework, and then we veneer that with porcelain, or it can be a monolithic prosthesis, which means full contour prosthesis. The monolithic prosthesis may have a modification for cutback of non-load bearing areas, like in the anterior maxilla for additional aesthetics, or in the gingival portion to allow for pink porcelain. Do we have any evidence for full arch monolithic zirconia prosthesis or full arch zirconia prosthesis veneered? Yes. We have a 2017 systematic review by Avi Bidra, and what the authors did, they reviewed the literature. They had almost 301 pieces zirconia full arch prosthesis, followed up to 8 years, and what they found was that the failure rate was very low. It was less than 2%, up to the 8-year follow-up. Porcelain chipping was the most common complication, only when the zirconia frameworks were veneered. And they concluded that this may be overcome when you use less veneered surfaces or no veneering, like in the monolithic fashion. Now, since that publication, there is a lot of additional research that came out. We have more than 2,000 additional full arch fake prostheses with up to 8-year follow-up, indicating a very promising survival rate of more than 98%. And here you see the patient that I was showing you in the beginning during treatment. This is the final definitive rehabilitation with monolithic zirconia prosthesis with gingival cutback to allow for the pink porcelain. Happy patient. We published that a year ago in the Journal of Prosthodontics. Now, what about 3D printing? You saw milling. Milling is the current standard for definitive prosthesis fabrication, but what about 3D printing? So when we say 3D printing, we can relate to study casts, surgical guides, ortho-aligners, custom trays, occlusal guards, provisional prosthesis, and digital dentures. Now, the only definitive restoration you can do in implant dentistry is a digital denture, a complete denture. You cannot fabricate any frameworks or full art prosthesis with 3D printing yet. It is still experimental. We can fabricate, though, a prototype, as I showed you. The prosthesis prototype can be printed or milled. I don't have data for that yet, but based on my own clinical experience of our team, we have to be a little bit cautious with the 3D printed prosthesis prototype if should the clinician decide to insert it in the patient's mouth for a long period of time. They tend to fracture. The fracture resistance is not as strong as the milled prosthesis prototype. So should the clinician desire to insert the prosthesis prototype and leave it for some time to check the occlusion and some other changes if they have been made, it might be better to actually mill a prosthesis prototype instead of 3D printing. 3D printing is only for short term. So the other field that we have interest in the 3D printing applications for full art cases is, of course, the implant cast. And the implant cast is generated from the intraoral digital scan. From the intraoral digital scan, this STL file can be used into the pipeline for a complete digital workflow, or for the emotional prosthodontist, as I say, that likes to have a cast in his hands, we can 3D print a cast. And we can then position repositionable analogs that fit and are snapped inside the appropriate areas of the implant cast. What is the evidence for the accuracy? This is also a hot topic. It's currently under investigation. We published the first paper, our team in JPT, in 2020, and we currently have multiple papers in preparation in conjunction with Master of Science students here at Tufts with my residents. So I'll show you a recently completed project. We had a reference cast, and we had different groups. We took conventional impressions with the open tray splinting technique, and we created a group, as we call it, conventional impression group. We fabricated stone casts generated from the conventional impressions. Those stone casts were saved. Also, we took intraoral laboratory digital impressions. And the digital impressions were also used, those STL files, imported into 3D printers, and we 3D printed implant casts. So we used the two printers with DLP technology, the Bego and the Straumann P30 Plus, and we also used a third printer from Form Labs that uses stereolithography technology. Now, each 3D printed group also featured 10 3D printed casts. We connected the repositionable analogs, and then we tried to assess the accuracy, the three-dimensional accuracy of those implant casts. How did we do it? We digitized the group of the stone casts and the groups of the 3D printed casts with a high reference scanner here, the 7 series from Straumann. And all these digitized casts, the STL files from them, were superimposed to the master, to the reference cast, to see the three-dimensional deviations. And what we found was that all the groups had less than 100 microns deviations, which is also, according to the literature, within the clinical threshold for acceptable fit, as we showed for our clinical study with Dr. Chochlidakis and with the clinical study by Dr. Yemt, that had reported that 200 microns is approximately the threshold for clinical fit. But we took it one step further, because for the average clinician, these numbers don't mean anything. So how accurate are these implant casts three-dimensionally? So we fabricated a reference prosthesis on the stone cast, and that reference was actually made out of zirconia so that it is rigid. This reference prosthesis was seated on all the generated stone casts from the conventional stone group and the 3D printed implant casts from the 3D printed groups. And we performed the single screw test, the screw resistance test, and we took X-rays and assessed in the laboratory the fit of the prosthesis on the stone cast to see if this prosthesis fits on the stone cast. How accurate are three-dimensionally those casts? I'll show you how we did it through this video. So you see one randomly selected stone cast, and you see the zirconia prosthesis fitted on the stone cast. The single screw test is applied on the terminal implant. You see assessment of the fit. X-rays were taken besides the clinical assessment of the fit. And of course, we also performed the screw resistance test by screwing all of the screws and assessing the fit of the framework. Periapical radiographs with a standardized manner were also taken to conclude the fit assessment. You see here the framework being assessed. And this is how it looks like. So, all of the 3D printed casts presented with accurate fit when the zirconia prosthesis was fitted on the casts. So all 10 out of 10 for the conventional, 10 out of 10 for the Bego, 10 out of 10 for the Form 3B, and 10 out of 10 for the P30. So all of the implant casts were clinically acceptable to be used for definitive prosthesis fabrication because the prosthesis that was fabricated on the master cast, on the reference, fitted also accurately on them. We also tried to relate the numbers of the three-dimensional deviations to the clinical fit. So since the P30 3D printed casts were the ones that had about 100 microns deviations, and all of these casts presented with clinically acceptable fit, we concluded that the mean 88 microns of deviation is definitely within the clinical threshold for acceptable fit. The data are currently under publication. And with that, I'm going to conclude all the 4 fields of the application of digital technology in the workflow for full arch implant rehabilitation, and let's draw some conclusions. So, the digital planning is scientifically and clinically validated, and it is a very straightforward way of treating the case from the diagnostic phase. The guided surgery is definitely scientifically and clinically validated, and it's a great and safe tool in our armamentarium when we treat the patient with dental implants for a full arch rehabilitation. Digital impressions are scientifically validated, but still clinically experimental. Like I said, we are conducting a lot of clinical studies and different groups, and that will be definitely more evidence will be published in the next year, and hopefully it will become clinically validated as well, because the results that we have been seeing so far are very promising. CAD/CAM prosthetics, of course, are scientifically and clinically validated. The same applies for the conventional workflow. And for the digital workflow, we are still clinically experimental. We have very promising results, but data still need to be published. Now, digital technology is a beautiful tool to use. However, how do you verify your digital workflow? And I would like to conclude my presentation with this because this is key. So the verification jig is crucial. And you can easily fabricate a verification jig intraorally by connecting temporary abutments or impression copings and splitting them together and then connecting analogs and pouring a cast that will serve as your verification jig. And you can also use the immediately loaded prosthesis. That's the best way, and it's a very simple and efficient way. You just, while you're doing your intraoral scan, even your assistant can pour a cast, and you can have a verification jig cast directly fabricated from the provisional. This jig cast will be essential for the lab technician because the lab technician will connect in the laboratory the variobase SRA abutments to your final zirconia restoration. So this way you will have no issue with passive fit. And the question is, are we there yet? I will tell you what the father of atomic theory said 2,500 years ago. He said that transformation and motion equals evolution. And today, with the digital implant dentistry, we can safely say that digital implant dentistry represents a revolution to our field. It is a great tool, a great vehicle that can take our fundamental prosthodontic skills and help us rehabilitate the patient in a streamlined way with efficient outcomes, shorter treatment visits. But of course, it's only a vehicle, it's only a tool. We definitely need to have these solid fundamental prosthodontic skills and surgical skills to be able to perform the dentistry. So digital workflow is feasible. It's very promising. A lot of clinical research is being done, and a lot of very promising results will be soon published. Still, we need our verification jig, and we need to have the solid fundamental surgical and prosthodontic skill to go and ahead and finish, complete the rehabilitation of the patient. And with that, I will conclude my presentation. Of course, all the clinical research that you saw here is part of a team and collaborative efforts of all my collaborators, which I'm indebted and happy always to work with. And I will be happy to entertain questions and in the Q&A session. Thank you for the attention. Dear colleagues, I hope you enjoyed the webinar. And we will go over now some of the questions that I see here from the audience so that we can clarify some questions or share some tips and tricks regarding the workflow, the digital workflow. So let me go over. A lot of questions are regarding the fiduciary markers, what brand they are. And I'm not getting any money from that company, but these fantastic fiducial markers that you can use both for your CBCT scans and for intraoral scans are self-adhesive markers from Beckley Medical. They are called CT Spot 120. CT Spot 120 from Beckley Medical. This is the company that you can find those. They are very inexpensive. And whoever wants can also feel free to contact me anytime on my email that you saw in the presentation or through social media, and we can connect and I can give more information. But they are very easy to find online. So this answers a lot of the questions. Another gentleman, another colleague asks, yes, the literature says about the accuracy of full arch impressions is comparable to conventional. Do we feel comfortable going from a full arch scan to final without a verification jig? I think we answered that. I answered that with the last slide. You always need a verification jig. I am comfortable going without it, but my lab technician still wants it so that he feels comfortable. And me as an emotional prosthodontist, I want to see the verification jig, so I always do the verification jig, which you can do it very easily with multiple ways. You can attach your immediately loaded prosthesis or your provisional. You can attach analogs, as I showed, and make an index cast. Or you can make a traditional verification jig, and from that, attach analogs and make a jig cast. So yes, make a verification jig that's still fully digital, because you use the prosthesis while you scan. Your technician can, your assistant can attach analogs and put the cast. What about the lower arch? We gave the solution to that. You can use the modified DDS technique with the anchor pins on immediate load or with the new novel scan bodies that we showed. Hello to Spain. Hello to different countries. Are there differences in accuracy of fit in printed versus mill prototypes? There is absolutely no difference. This is unpublished data, but we don't need publications for anything. That's based on my clinical experience. We do a very large amount of reconstructions, full arch cases with digital approach. A lot of the times, even for us to check, we use printed and milled prototypes. No difference. The anchor pin technique, a colleague asks, if you do the anchor pin technique after the implant's healed, no, you don't do it because you don't want to numb the patient and put bone pins. You use the modified DDS with the technique that I showed you for the mandible in the end, the one we just published. I will be happy to share all the publications. If somebody wants to email me, and I can share all these things with you. Another colleague asked, where is the link between DDS and accuracy? The technique will surely save all the information we need to fabricate the final prosthesis, but I can't get how this method will ensure passive fit. The scan bodies register the implant position, and the prosthesis registers the tooth position. So when you merge the two files, you have everything. So it's fitting accurately. Jonathan, hi. He asks, with the DDS technique, the laboratory technician still needs to fabricate a verification jig for the cementation of the prosthesis of tie bases, right? Yes, that's what we said. We can always make the verification jig. Any comments on photogrammetry and accuracy versus regular scan bodies? I don't have experience with photogrammetry. It's a very promising technology. I have prosthodontist friends of mine that use it. From their experience, again, not mine, from colleagues' experience, they get very nice results, but I like to have information of the teeth and of the implants. And with a simple intraoral scanner, I can get both information with my DDS technique. If you have photogrammetry, you still need to take an intraoral scanner for the soft tissue. So for me, why would I have photogrammetry and intraoral scanner? I just get a scanner. It's more efficient for my workflow and for my profitability. Again, questions about the stickers. We solved this. Do you feel that a good way to start is getting a scanner? Yes, because intraoral scanning can be also a great communication tool for your patients, because you can show them, Mrs. So-and-so, here is decay on the tooth. This is a cracked tooth. You're missing a tooth here. It's not only for full arch implants, so it's a great way. It can also reduce the cost in the long term, because you can, take a digital impression, send it to the lab, and you save all this hassle with the conventional impressions. Hello to Brazil. I have lots of Brazilian friends. What about another friend asks, what about Straumann abutment selection with this type of hybrid prosthesis? What Straumann abutment reference do you prefer? I like to build my full arch cases at the abutment level, on the multi-unit, or SRA as Straumann calls it. So I connect my zirconia prosthesis with the vario-base SRA abutment. Another friend is asking, so what if we want to provisionalize at the time of surgery but not use an analog pickup like you showed? Hard to use the DDS technique with bleeding. Is this where photogrammetry comes in? Sure, it could be, but you will still have to take an impression of the soft tissue. So if you take a scanning of the soft tissue, it will still be bleeding. What I find in my hands, as a clinical tip that I can share with my colleagues, is that I like to use the powder, as I showed you with the anchor pin technique, the DDS with the anchor pins. I like to use a powder, like any type of CEREC powder or intraoral powder, just to reduce the reflection from the blood when the blood oozes from the flap. But in any case, when there is blood, of course, the scanning becomes harder. What intraoral scanner were you using? Any brand preference? I'm not getting paid by any company. I personally use optical sectioning scanner, or Trios, and I'm very satisfied with that. Not sure if I got the lower fiducial market idea. Would you use a higher screw that can hold both the scan body and the temp abutment? The novel scan body and the temporary abutment are interchangeable. The key is the guide pin. The guide pin connects the scan body to the implants and connects the temporary abutment to the implants. So the guide pin sticks out, and you can stitch the two scans with that guide pin. This is a fantastic idea that Dr. Marin is thought in collaboration with myself, and that solves any situation. This you can apply to any situation. That's really the solution. Every company should copy that, by the way. For mandibular scan, one could use an impression transfer screw, at least for us, at place of temporary abutment screw. Yeah. With optical scanning, doesn't the accuracy decrease the farther the implants are apart cross-arch? Also, stitching issues going cross-arch, how you overcome these limitations? I know there is a lot of things in the literature that if the implants are too far apart, stitching is harder. And it's true, it's harder to get an accurate intraoral scan. So very easily, just attach the fiducial markers that I showed you in between the edentulous areas that will help the scanner stitch together the files. This is not for superimposition. This is just a technique to help stitch the files better. You can put powder and you can put stickers, or you can put some flowable composite, whatever you want, because sometimes the edentulous areas are harder to cut, are hard to register. These are the tips I would like to share with you. And I would like to invite you all to the Straumann Symposium now. It's going to be live after a very long time in Arizona. We also have a nice hands-on there to share all tips and tricks about intraoral scanning, especially for the full arch. And of course, like I said, everybody can contact me. I'm very happy always to exchange information with colleagues, because that's how we learn and we grow and we help each other. And become also more profitable in the private practices. So I would like to help you for attending the webinar, and looking forward to see and meet all of you in future meetings. Good night.